Hello, welcome back. In this video, we're going to see what we can do with proper fractions with repeated factors. Let's start with an example. Express this fraction as partial fraction. So you can see that we have a repeated factor here. And if you remember from the first video, we can write this partial fraction decomposition as a over x plus 1 plus b over x plus 1 squared plus c over 2x plus 1. And our discussion in the first video was that we cannot know whether we have this fraction with a over x plus 1 or this fraction b over x plus 1 squared in the partial fraction decomposition. And the chances are both of these fractions may appear in the decomposition. So we have to consider all possible cases. Now, what we're going to do next is that we're going to equate the denominators. So we're going to multiply this by 2x plus 1 and x plus 1. We're going to multiply this by 2x plus 1 only, and this by x plus 1 squared. And this way we can get rid of the denominators from both sides. So this means I can only write 11x squared plus 14x plus 5 equals a times 2x plus 1 times x plus 1 plus b times 2x plus 1 plus c times x plus 1 squared. Now I find substitution method easier than the simultaneous equations method. However, after I solve the question, I'm going to present a simultaneous equation solution as a picture so that you can check your answers if you use that method. So we can start with substituting x equals -1, which is the root of this factor. If I do so, I can calculate the left-hand side being 2, and on the right-hand side, you can see that the first term and the third term includes x plus 1. So when I substitute -1, they become 0, and these terms just go 0. So basically, I calculate the second term. So it's -1 times 2 minus 2 plus 1 minus 1 times b minus b. Hence, b is -2. For x equals -1 over 2, which is the root of this factor, I can find the left-hand side to be 3 over 4 equals... Now, when I substitute -1 over 2, the first and the second terms will go 0. So basically, I'm calculating the third term. So it's -1 over 2 plus 1, which is 1 over 2. Squared is 1 over 4, so I have 1 over 4c. Now, this implies that c is 3. Well, I ran out of roots to substitute, but I still have to find a. So how am I going to find a? Well, this is substitution, so I can choose any value of x to substitute into this equation. And also I know the values of b and c. I can substitute those values into the equation as well, leaving a the only unknown. And then I can solve for a. So let's do that. Let's say, what happens if x is 0? Well, if x is 0, the left-hand side will be 5, and the first term will be 0 plus 1, 1, 0 plus 1, 1. So I have these two terms being 1. 1 times 1 is 1, so I have a plus 0 plus 1 is 1, and b is -2, so I'm going to say -2. And then c is 3, and 0 plus 1 is 1. 1 squared is 1, so basically I have c being 3 here. And you can see that this is 5 equals a plus 1. From here I can find a to be 4. Now, if you don't feel like doing all these calculations mentally, you can write these down and then do the calculations. That's totally okay. But this much of work is sufficient to collect all the marks in such a question. Now that I've found a, b, and c, I refer to the question. The question asks me to write this fraction as partial fractions, so I have to substitute a, b, and c into this decomposition. So it will be 4 over x plus 1 minus, because b is minus, 2 over x plus 1 squared plus, well, c is positive, so I don't need to change the sign, 3 over 2x plus 1. So that is the partial fraction decomposition of the given fraction here. Now you can pause the screen when the simultaneous equation solution appears if you want to check. Otherwise, it will disappear within the next 4 seconds. Now let's look at this example. As you can see, the denominator is not given in factored form, so an additional step you have to factorize it. But this one is not hard to factorize. Okay, so let's start with writing the expression x squared plus 5x plus 3. Note that I never touch the top part. I mean, I never try to factorize it, even if it is factorizable, because there is no point. All I care is to factorize the denominator, which is, in this particular question, x squared times x plus 1. So this is going to be equal to a over x plus b over x squared plus c over x plus 1. Now let's equate the denominators. It's going to be x times x plus 1 here, x plus 1 here, and x squared here for expanding these fractions. And getting rid of the denominator, we're going to have x squared plus 5x plus 3 equals a times x plus 1 plus b times x plus 1 plus c times x squared. So let's start with substituting x equals 0. That's the root of the factor here. The left-hand side will be 3, and you can see that the first and the third term will cancel out to 0. So we will calculate the second term. It's going to be 0 plus 1, 1. So it's going to be b. Well, b is equal to 3. Very easy. The second factor's root is minus 1. So let's substitute that. It's going to be, well, this time the first two terms will be cancelled out. And I'll be calculating the third term. And left-hand side will be minus 1 equals, well, minus 1 squared is 1, so it's going to be c. Now, I know b and c. All I need is a. Well, I can substitute x to be 1. So the right-hand side will be 9, and I know b and c. I'm going to substitute them along with the value of x. So the right-hand side will be 2a plus 1 plus 1 is 2, and b is 3, so 2 times 3 is 6. And the last term will be 1 squared is 1, and c is minus 1. Minus 1 times 1 is simply minus 1. So I have 2a plus 6 minus 1 on the right-hand side, and left-hand side is 9. And I'm going to end up with 2a being 4, hence a is 2. Now I know all the constants a, b, and c. Let's refer to the question now. It asks us that this fraction can be written in this form, where a, b, and c are found. Well, we stated the values of a, b, and c. Most probably it is enough to stop here, but my suggestion is write down the partial fraction decomposition, so substitute the values here. So it's going to be, we can say hence, it's going to be 2 over x, well, b is positive, so I keep plus, 3 over x squared, c is negative, so I go like minus 1 over x plus 1. So this is the partial fraction decomposition of the given algebraic fraction. And here comes the simultaneous equation solution. Well, needless to say, I stop here, but if need be, you should be writing the partial fraction decomposition after finding the constants a, b, and c. Now, one last note before we finish. You can substitute any x value you'd like. In the first example, we substituted 0 for x, but as you can see, 0 was one of the roots for the factors of the denominator, so we couldn't substitute 0, and the next easier option was 1. So generally, it makes sense, of course, to substitute the smallest possible x values, unless they are the factors of the denominator themselves. So basically, you can just choose any x value you'd like. Just make sure that it is easy to calculate. For example, try not to choose negative numbers because there will be sign issues and it's going to be risky. You may make mistakes. The next video will be about improper fractions. Thanks for watching.